Okay, we have here problem number 29, and that is in chapter 16 now. So you were asked about ethanol or something like that, but it doesn't really matter. All you need to do is pull out the number. So you have the temperature at which it boils and the energy needed to make it vaporize, and those are in units of kilojoules per mole. And then it asks you about the entropy. So you need to remember the units of entropy is joules per mole degrees Celsius. Well, once you look at the units you have and the units that you want, hopefully a lot of you guys can see that, or all of you guys can see that all we need to do is divide this number by degrees Celsius and then go to joules. So we have 27.5 kilojoules divided by 35 degrees Celsius, and that's per mole. Okay, and when you do that, let me check my cheating book, number 29, you're going to get, oh, I made a mistake. It's not in degrees Celsius here. This is kelvins. So we need this to be in kelvins. So we just add 273. Okay, so what you have now is that divided by 273 plus 35, and you're going to get 8.93 times 10 to the negative second kilojoules per Kelvin mole. Okay, but remember that delta S is the tricky one, and it needs to go to joules, so we need to divide by kilojoules, 1 kilojoule, 1,000 joules. So we get to multiply here, and we're going to get 89.3 joules per Kelvin mole. The last thing to think about is the sign. If we're boiling the water, is it getting more organized or more unorganized? And it is getting more unorganized. So there is an increase in this order here. So this delta S would be positive. Okay? You can actually derive this because we know going home minus T delta S, going home to supper. And if it's boiling, it's actually at equilibrium, so G is equal to 0. So what we get is negative delta H equals negative T delta S, divide by negative T, and we get delta S equals delta H, divide by T.